This is number 5 on the AP Physics 1 problem set, chapter 2. And it says a car parked on a hill comes out of gear and begins to roll downhill. The acceleration of the car is 3 meters per second squared. And then I asked some questions. This is a two-part problem. We have to do the first part, figure out what's going on there. Matter of fact, we want to find the velocity after 5 seconds and the distance traveled after 5 seconds. The second part, it goes up. At 5 seconds, it reaches the bottom of a hill and begins to climb up the hill. That's what I have drawn here. So the second part, we're going to find some other things, but we have to use information from the first part. So this is a part 1 and a part 2. I got my little Volkswagen van or truck drawn here. And so what do we know? We know that the acceleration is positive 3, so that's 3 meters per second squared. We know the initial velocity is 0 because it's parked at rest when it starts rolling. And we know the time is 5 seconds. So I want to know the final velocity, V equals, down here at the bottom when it gets right here after 5 seconds. So I believe, and you have to check me on this, but on the equation sheet I gave you, I think it's the first one, I think. Anyway, it's this one, V equals V naught plus AT. So V equals 0, that's my initial velocity, plus 3 meters per second squared times 5 seconds. That gives me a positive 15 meters per second. So when this little van gets right here, our truck, and it is moving at 15 meters per second. And then the distance, what distance is it going to go? So this is not A. B will make a different color. Oops, I need to do that. Different color, let's do red. There we go. This will be B. Okay. What distance did it travel? How far did it go? Well, I'm going to say this is x naught and it equals 0. This is t naught, it equals 0. This is down here is the t equals 5. And down here is x equals something. I don't know what that is. So, let me erase this. Sorry. Go back to my red color. So 5 seconds is right there. X, I don't know. So, x equals x naught plus v naught t plus 1/2 at squared. If I use that one, that will give me the position. It's x equals 0 plus 0. This whole thing is 0, so it's 0 times 5, but 0 times 5 is 0. Plus 1/2 times 3 meters per second squared times 5 seconds. Don't forget to square the 5 seconds. So basically it's x equals 1.5 times 25, and that's going to give me 37.5, or at least that's what I got. 37.5 meters. That would be the answer for how far it went. So from here to there has to be 35 meters from the information I got. Let me make this, oops, go back. Let me make this a little bit larger page by, there we go. Okay, so what's the next part? The next part says the car's at the bottom of the hill after 5 seconds. It begins to climb up a hill. The new acceleration is. So let's do this in green. So the new, this is C. The new acceleration is negative 5.0 meters per second squared. How far will the car travel before it comes to a stop? Comes to a stop means the final velocity is 0. initial velocity is now the velocity right here. This was the final velocity in part 1, but in part 2, that becomes the initial velocity, 15 meters, because that's what it starts with up the hill. And then, what else do I know? I think that's it. I want to find how far. Again, we're going to say x naught equals 0, because that's easy. If I may, see, I get to choose my coordinate system, and since this is part 1 and part 2, for part 2, I'm going to say this is x naught, and it equals 0. So then x is what I'm looking for. If you look at your equation sheet, it's v squared equals v naught squared plus 2a x minus x naught. So that's going to be 0 equals 15 meters per second. Square that. Plus 2 times negative 5 meters per second squared times delta x. I don't know. That's delta x right there. That's a negative 5. Of course, bring your 2 down. That's my 15. I got to square that. So put this in your calculator, and you're going to subtract the 15 over here. I'll let you do the algebra this time. But you should get, or what I got was x equaled 22.5 meters up the hill when I did the math on that. So, yep. So it'd be 15 squared divided by negative 15 squared divided by negative 10 in the end, and that's what you're going to get. And I think that's the last part of that one. So that's how you do a 2-part problem. A little bit easier than the one we did in class with the rocket, but similar really. It's just not quite as complex.